Assistant at the Center for International Strategic Studies, Islamabad. It is my honor to serve as a Master of Ceremony on behalf of CISS on the second day of our international conference. Now we will begin the fourth working session on the impact of quantum, cyber technologies, and autonomous weapon systems on deterrence, which will be followed by an interactive session. Now I will invite Ms. Anam A. Khan, Associate Director at the Center for International Strategic Studies, Islamabad, to please moderate the session. Ms. Anam A. Khan is a project staff at the European Research Council-funded Third Nuclear Age Project and a mentor at the United Nations Office for Disarmament Affairs. She is currently enrolled in the PhD program of Defense and Strategic Studies at Quaid-e-Azam University, Islamabad, and is a former visiting PhD scholar at the University of Leicester and a former CTBT Research Fellow. She has worked with Pakistan's Strategic Plans Division at the Arms Control and Disarmament Affairs Branch for a decade up until July 2023. Over to you, Ms. Anam.
Thank you very much, Hasib. Good morning, distinguished speakers, guests, and colleagues. Welcome to the session 4 of our international conference. It is both a pleasure and a privilege to moderate this important session in the presence of such esteemed speakers as well as honorable guests. We are honored to have with us Mr. Wildesav Shernafsi, Dr. Jessica West, and Dr. Rizwana, as well as Dr. Leticia Shesari online. I would like to request the speakers to please come on stage. I hope Dr. Leticia can hear us. Okay, perfect. So when we think of deterrence, we usually imagine power dynamics and strategic doctrines. But what really happens when these dynamics are reshaped by emerging technologies like quantum computing, cyber vulnerabilities, and autonomous machines? We are here not just to explore these shifts, but we are also here to understand how they change and challenge long-standing principles of deterrence and stability in the region and beyond. This session brings together global thought leaders. They are here to address one urgent question: how do emerging technologies alter the landscape of nuclear deterrence? Their expertise spans from cybersecurity, international law, autonomous systems, and quantum computing and technologies altogether. And they will offer us both depth and diversity through their perspective. I'll give some session guidelines. For example, each speaker is kindly requested to keep their remarks in under 20 minutes. I would give a gentle cue after 2 minutes are remaining. And the question and answers would be held at the end of the session, and you need to kindly note your questions. We encourage concise, respectful engagement, and I would really request that your phones are turned off. So we start with our first speaker, Mr. Wildesav Shernafsky. He is going to talk about the impact of quantum technologies on nuclear deterrence. Quantum technologies, especially quantum computing and communication, are no longer theoretical. As adversaries compete for quantum supremacy, nuclear deterrence and its strategies may be undermined or even reshaped. What would it mean if command and control or encryption could be compromised altogether? So if I tell you a bit about this eminent speaker, Mr. Wildesav is a research assistant with CIPRI Weapons of Mass Destruction program. He's focusing on nuclear disarmament and non-proliferation. He also contributes to CIPRI's Elva Maridil Center working group on nuclear disarmament, and he's also working on international law. Formerly, he was a research associate at CISS. He holds a dual MA in non-proliferation from Middlebury Institute of International Studies, Monterey, and Moscow State Institute of International Relations, and also a BA in International Relations from Ural Federal University. So, Mr. Shernafsky, we're pleased to begin with your insights. Over to you.
Thank you very much for your kind introduction. And I will also mention that you have pronounced my last name almost perfectly, which is something that even native Russian speakers don't always do. So this is just a testament to how much preparation is going into organizing this event, which is, I think, is very much appreciated by all of us as speakers. I believe I had a couple of slides. Would that be possible to show them? Well, not really a couple, a bit more. Ah.
Please switch on his slides.
Is that? Okay, well, I'm not sure if the, okay, perfect. All right, thank you so much. So just one disclaimer I wanted to make before starting is that I do not have a technical background, so I very much come at these issues from policy and sort of nuclear risk mitigation perspective. So I just thought that would be important to mention. My work at CP right now focuses on the intersection between nuclear weapons and AI. And therefore, in the presentation, I will touch upon some of the aspects of military quantum technology use relevant for the nuclear domain from this angle. Broadly speaking, quantum and AI as technological fields are, of course, fundamentally different in how they work. But they do share some similarities in terms of potential for military applications and resulting impact on the environment where nuclear decision-making will be taking place. So just to list some of them, they are both thought of as technologies that will act as force multipliers and expected to improve existing strategic capabilities. Many of them related to data collection and processing to enable improved intelligence, surveillance, and reconnaissance, targeting, and secure communications. Therefore, because of that, they are expected to impact strategic stability and existing deterrent practices through altering these capabilities. Finally, because of this, both technologies are sort of at the center of a new kind of arms race involving competition over computing power, algorithms, and data. In terms of maturity, however, quantum technology is still very nascent. Most of the capabilities that experts discuss are not yet, have not yet materialized. So quantum devices remain difficult to build, and the timeline for actually achieving those transformative quantum applications remains uncertain. And the AI is obviously much further along, and we had a lot of brilliant speakers yesterday speak about AI in more detail. I will note, though, that the quantum technology in the future is expected to further amplify those already existing effects of AI on nuclear deterrence and serve further as enabler for military AI potential. I will start with AI as sort of the more mature technology and then talk a little bit more about quantum as an enabler. So in the last few years, as we've heard yesterday, there's been sort of a leap in performance of AI systems in a number of areas relevant for military use, including signal recognition of signals such as acoustic electromagnetic signatures, recognizing and classifying objects and pictures and videos, data management tasks, and other applications connected with data analysis and collection. And so advanced AI is often discussed as having the potential to further enhance capabilities in all elements of nuclear deterrence architecture, and this picture is from the CIPRI study from 2020, which I think is still very much relevant and a good illustration of how many different potential uses AI can find in nuclear deterrence. Once again, we've heard our colleagues talk about this yesterday, so I will not, of course, focus and go over those things again. For this presentation, I did want to highlight several application areas where I think we're already seeing either significant drive and investment on part of nuclear armed states into using AI for nuclear relevant applications, or we're seeing already some effects on the nuclear domain. So out of these emerging sort of areas of application, the ones I want to highlight first is AI-enabled space systems. And here AI comes into play most prominently in three interconnected applications. First of all, it's intelligence, surveillance, and reconnaissance. So use of AI for satellite imagery and geospatial data fusion and analysis. You know, for the nuclear domain, this is relevant mainly in terms of improvements in ISR capabilities to aid in detection, tracking, and targeting of nuclear delivery systems, for example, even mobile launchers. We see significant investments from states in this area. The US has a number of projects to integrate AI across its satellite data collection and processing networks. For example, India's space agency has announced they're planning to launch AI-enabled surveillance satellites over the next 5 years to enable their ISR capabilities. So this is one area where I think it's kind of a natural case use for AI, and this is where we actually see a lot of investment and a lot of development. The second one is early warning and missile defense. So here again, I think the US is probably the most prominent example, with the US Space Force and Missile Defense Agency investing in capabilities to integrate AI across their missile defense systems, including ground-based launchers and radars and space sensors. So thinking of it as an AI layer on top of sensor networks to coordinate shooters, interceptors, and sensors. There are some other examples, for example, use of AI, interest in using AI in air missile defense forces in Russia, for example, in the S-500 air defense system. So that's another area where we see some development. Finally, for space, it's space domain awareness, especially now as more states are investing in satellite constellations. This use of AI for improved coordination and sort of movement to space is going to be more important. And systems, nuclear-related systems which rely on space assets here are critical. I will also add there are some projects aimed at tracking anomalous behavior in space. So, for example, detect threat to satellites, constellations. So that's another use. Another area is cyber offensive and defensive operations, but I will let my colleague Jessica to speak a little bit more about that. Her presentation focuses, I think, on cyber, so I won't go into detail on that, but this is also an area where it's a natural use case for AI, where we see states investing into testing and kind of red teaming the use of AI over cyber defense and offense. So the area is the naval domain. So I think here the underwater use of AI for locating submarines is especially, nuclear submarines is especially relevant. One example is the AUKUS agreements. The states involved in AUKUS, Australia, UK, USA, are investigating how AI can help in tracking submarines with greater speed and accuracy, relying on underwater acoustic signals and sonar data analysis. A number of other states also doing this. The fourth area is the use of AI in conventional weapon systems with potential strategic effect. Here I wanted to highlight, for example, the recent Ukrainian drone attack on Russia's strategic bomber base, which is sort of an example of non-nuclear weapon state using AI to target nuclear assets of its adversary. In the changed Russian nuclear doctrine, for example, we can see that drones were added as one of the sort of ways of attack on Russia relevant for the potential decision to employ nuclear weapons. So that's an example of clear effect on nuclear posture. Finally, I would say there are also examples of AI being used for nuclear weapons delivery specifically. There's a Russian nuclear-armed autonomous underwater vehicle called Poseidon, which is reportedly being developed and relying on advanced AI. The US B-21 Raider, for example, is designed to undertake crewed or uncrewed operations in collaboration with other crewed or uncrewed aircraft, so drones. That's even though states agree that sort of decisions to use nuclear weapons should be left to humans. There should be always human in the loop, yet we do see some integration into delivery systems. And this, again, was mostly covered by colleagues yesterday, so I won't dwell on it for too long. But essentially, just to the long and short of it is that in terms of strategic risks, I think those sorts of applications are causing arms racing and instability, as nuclear assets are becoming to be perceived to be under threat by nuclear armed states. And if a state doubts the survivability of its nuclear forces, due to advantage gained by, for example, AI-enhanced conventional capabilities, it may also adopt riskier nuclear postures, as was the example with Russia. And I also wanted to highlight really in the nuclear field specifically, the lack of data or sort of a very contested and unclear environment in which nuclear weapons operate and which nuclear deterrence operates really limits the sort of effectiveness of AI systems and creates more opportunities for technical mistakes or errors or misuse of AI. Oh, sorry. Thank you. Yeah. Now, and of course, there are also numbers of risks stemming from interactions between AI and humans and from technology itself, which Alicia Zaltini spoke yesterday about, but I'll move on in the interest of time. So moving on to quantum technologies, I think the experts tend to sort of group them into three broad categories of quantum computing, quantum communications, and quantum sensing and imaging. Each category harnesses different quantum effects to overcome limitations of sort of traditional approaches to computing, the ones that exist today, in computing, in communication, in sensing. Yeah, thank you. Essentially, the effects from all of those quantum applications may, first of all, enable some of those AI applications that I talked about previously, and also compound on that and add additional strategic instability. So quantum computing is primarily relying on so not to go too much into technical detail, but quantum computing, so it uses quantum bits for counting, which allows quantum computers to process information in ways different from classic binary systems. So we're talking about faster, more powerful computing. So this can, first of all, accelerate AI model training and real-time data processing, which enhances already existing sort of AI effects. When I were talking about military use. So data processing and maybe decision making in high stakes scenarios. I would also say that improved reliability and scaling of quantum processing reduces the time needed for AI algorithms to train and to learn from data, for example, from ISR data sets, for example, potentially enhancing those identification and decision support and targeting tasks that I spoke before about. One final note is that quantum computing also poses new security risks, as it may be able to break many of the existing encryption methods, which can compromise sensitive communication networks, of course, including in nuclear-related systems. Quantum communications is sort of the next set, which is also tied to AI use. First of all, it's quantum communications leveraging those effects of quantum to create secure communication channels. So that would be relevant both for networks on Earth and via satellites, enabling more secure data transfer, which is less vulnerable to hacking or cyber attacks, distributed quantum computing, and more distributed networks of quantum sensors. In the military context, we're talking about enhanced battlefield communications, sort of coordination in contested environments, and safeguarding command and control networks from cyber threats. so here, obviously, sort of the role of the AI is already playing in enhancing security and privacy of communication networks, may be further enhanced by quantum communications. Finally, and I will stop here, quantum sensing in imaging, they take advantage of quantum properties to measure physical quantities with more accuracy. So here we're talking about quantum sensors collecting richer, faster, and more precise data for AI to analyze. Quantum sensing and imaging can also enable navigation systems, quantum navigation systems which are more resistant than classical or traditional systems like GPS, for example, which brings obvious benefits in terms of targeting and navigation of assets in contested areas or covertly. And some of the quantum radar and other imaging methods offer enhanced ISR capabilities, enabling further detection and tracking of hidden or obscured targets, working in tandem with AI systems in these ISR applications. So I will stop here, but I will be also happy to hear your comments and questions. I'll hand it back to our moderator, right?
Yep. Thank you very much. Brilliantly timed, Mr. Chernavshik, just within 15 minutes. Thank you for setting up the stage for not just quantum tech, but also other technologies, which other speakers are also going to talk about. The most striking part of your talk was that despite quantum being at the nascent stage, it can still have implications towards arms race, and also how quantum would contribute to AI data sets when it comes to ISR capabilities. Moving forward to speaker 2, now we have Dr. Jessica West. She'll talk about cyber threats to NC3 infrastructure and the implications for nuclear deterrence. Dr. Jessica West is a senior fellow at the Center for International Governance and Innovation, Canada, and a research fellow at the Kinred Center, Credit Union Center for Peace Advancement. She specializes in outer space, peace, and security, with a focus on humanitarian, gender, and inclusive approaches. Her work engages with UN bodies on space safety, AI, and cyber issues. She holds a PhD in global governance from the Basile School of International Affairs. Dr. West, we look forward to your presentation. Welcome to Pakistan from Canada.
Thank you. While my slides get loaded, I just want to mention that I don't think I've ever had such a warm welcome as this community. So thank you so much for having me here. It's really been lovely. So my home institution is actually Project Plowshares, a Canadian Peace and Research Institute, not the American Plowshares Fund. They have money, we need money. That's a big difference. And as you can tell from my bio, my main line of work is on outer space. And so you might be thinking, what am I doing talking about cyber and nuclear? First, I was asked to. Second, both issues are highly entwined with outer space, which you'll hear on the next panel. And third, I'm taking a cue from Dr. Evans' talk yesterday. I'm pitching myself to you as a bridge builder. So bear with me if some of my technical analysis isn't as sharp as core experts in the field, but I'm trying to link together a lot of ideas that flow through my work. And this metaphor of a bridge is really perfect for what I'm going to talk about, because I'm picking up on a core theme from this week, which is emerging technologies aren't siloed or individual anymore. They are highly entangled with one another, and they create compounding and unpredictable outcomes and risks. And I'm going to try to make 3 core points. The first is that I think cyber and digital technologies are undermining the foundations of nuclear stability. The second is that this is amplified by the fact that cyber is really the conduit of these other emerging technologies, AI, quantum, and space, which compounds the risk. And the third is, I think humans and human judgment are really key to prevention and to stability and to deterrence. And I think we're losing space for that, not only within the technology domain, but also in the diplomatic world. So what do I mean by cyber? I'll admit that's a word that kind of makes my brain glaze over sometimes because it seems vague and hard to picture. And I like to think of it instead in terms of digital technologies. And so cyber is really the digital backbone, the technologies, the systems, the networks through which we create information, we store it, we send it and transmit it, and we manipulate it. And it's the connective tissue, really, of a lot of these other emerging technologies that link technical systems, data, communication to the physical world. And I think reminding ourselves that everything we're discussing is linked to the physicality in which we live is really important, even though it might take place in a non-physical world. And really, cyber runs through everything. Satellites, nuclear systems, computers, my smartwatch, even my toaster oven, I think, has cyber connectivity in it. It's hard to escape the cyber world these days. It's everywhere and it touches everything. But this extensive connectivity is also a real source of systemic vulnerability. I think it's important to point out that it's not a nexus. And I'll admit, I'm the editor of an essay series called the Cyberspace Nexus, and I hate that concept, especially for cyber, because really cyber is a multitude of points of connectivity and a multitude of sources of vulnerability that start with supply chains, human access to systems, every digital component within different technical systems, communication links through which the information flows, end user capabilities. It's a nebulous, it's not a nexus. And this nature of the connectivity, it's complex, it's fast, and it's really hard to contain. Digital risks, when we think about the nuclear world, they're not hypothetical. Anyone who's clicked on the wrong link on an email or whose mother has called them in a panic because she's clicked on the wrong link on an email understands that the risks are real and they're everywhere. And they've long haunted nuclear systems because they date back to the early nuclear age. They date back to the computer age. As early as the 1970s, we had false warnings caused by malfunctioning chips in computer systems. In the early 80s, RAND was actually running simulations and studies and warning about cyber vulnerabilities. Of course, the internet wasn't even public yet. The 1990s, the US discovered backdoors in critical military software. Stuxnet, I hate that word, in the 2010s is probably the most infamous nuclear cyber incident where physical damage on Iran's nuclear infrastructure was created through a line of code without any physical access to the system itself. Moving forward to today, there are reports that at least one nuclear-armed state has experienced compromised communications. And civilian nuclear systems have also been affected, including India's civilian nuclear facilities and an air-gapped, so a system that's not connected to the internet in Germany has also been affected. And the lesson here is that digital infrastructure is always exploitable. There's really no safe space. Many experts also believe that even nuclear submarines could be made vulnerable. So if this isn't new, what is new? My prof used to always ask me that. I think it's the scale, scope, and speed of the vulnerabilities that we're dealing with today and the extent to which they can cascade. And this cascading effect really changes how we think about warfighting and deterrence. So I'm Canadian, but one of my favorite classes in high school was American history, and I think it's because it was just so much more interesting than Canadian history, where we talk about peace, order, and good governance. For a teenager, that's just kind of blah. It's great now, though. So I can't tell you exactly where Lexington and Concord are located, but I do remember that they're known as the shot heard around the world that set off the American Revolution. And when I learned about World War I, we talk about the assassination of Archduke Ferdinand as the spark of the war. And during the nuclear era, we have had sensors trained around the world looking for signs of a missile launch that might indicate a first strike in a nuclear conflict. But I think with the growing emphasis on cyber or digital warfighting, we're shifting from these visible, physical, kinetic signals of war to silent digital triggers, to pieces of code, to odd malfunctions, which may have been lurking for years. And I'll give you an example that brings you back into my world of space security. The long-standing wisdom for years has been that the first strike in a nuclear conflict would happen in space through cyber means, likely efforts to disable or blind nuclear early warning command and control systems. And I think we saw a version of this assumption play out recently in Ukraine, where prior to physical conflict, we witnessed a cyber attack that crippled the Viasat satellite network by targeting vulnerabilities in end-user modems, so not even in space. But it had the effect of denying system-wide access, of disrupting the ability of Ukraine's communication and coordination capabilities when it came to defense and it rippled across civilian users in Europe. And this was the first shot, so to speak, but it wasn't physical, it was digital. And while it wasn't a nuclear conflict, it gives us some insight into the integrated nature of our technology systems today and how they affect the battlefield and how we think about deterrence. It's also so common. Cyber tools are incredibly appealing because they can have far-reaching consequences. They are easily deniable and almost impossible to publicly attribute. They're easily accessible. It's not only every major nuclear state that has advanced cyber capabilities, it's most states. And that makes them very escalatory because they seem not escalatory, and that means we're more prone to use them. But we've seen how this entanglement can lead to unintended consequences. And I think effects on nuclear command and control are one of those. I want to be clear that every component of nuclear systems are vulnerable to cyber. But if we zero in on nuclear command and control, we're talking about the nervous system of our nuclear arsenals. I think yesterday Alice talked about this constant loop of data and decision making. And that's how we detect threats, how we communicate the threat, how we communicate with each other and weapon systems, and are able to launch if necessary. But it exists in a fog of war, and I think digital vulnerabilities make the fog thicker. So interference can look like so many things. Tampering with early warning data, so a sensor that might be misbehaving, having your communication spoofed or cut off, disinformation in data systems, false alarms, and I would also add manipulation of the social environment in which we're making decisions, per Dr. Evans' talk yesterday on the psychological aspects of deterrence. And it could be an accident, and it can be incredibly difficult to differentiate if something's intentional or if your system is malfunctioning and you experience, quote unquote, a normal accident. To complicate things further, these platforms are deeply entangled with other emerging technologies per Vlad's presentation. And so AI and quantum and space are all part of this medley of faster and faster technology, data, and decision making, but they're all also subject to misinformation and false alarms. And so I like how Dr. Han yesterday said both good and bad. And so on the good side, I think AI and quantum can help protect cyber systems, but they can also help accelerate capabilities to attack cyber systems. So I think it was Dr. Selleck yesterday who talked about counter capabilities. And so this loop continues. And I think what we're facing is really the collapse of the logic of nuclear stability. It requires credible and reliable strike capabilities, which cyber make uncertain. It relies on clear signaling, but cyber muddies the water. It assumes there's time to properly assess and respond, but technology makes that window shorter. It depends on human control, but these systems are increasingly pushing the boundaries of our abilities to do that. And I think they really undermine the two core foundations when it comes to nuclear capabilities and deterrence, which is the belief by yourself and by others that the system is always available and will function as needed, and that it will never be used without authorization. I think that is being inverted in many ways. And it's not me saying that. We've had many warnings out of the United States military, including former STRATCOM commanders who have said we can't guarantee that these systems will work when we need them. And I think that makes deterrence crumble. So where do we go from here? I've put up images. Oh, this is my older slide. I had Dr. Strangelove up there. So two of my nuclear heroes, Dr. Strangelove, and yeah, why am I forgetting the name? Yeah, go for it. I have it written. Yes, Stanislav Petrov. I have too many names written in here. But when we look back at history and we look at why there are heroes, it's because they show us that deterrence and preventing nuclear catastrophe is really a human endeavor. It's not nuclear weapons that gave us stability. It was human efforts to not have horror emerge and to create understandings and to create communication that gave us the stability of the nuclear era. It was built slowly and over time and painstakingly. It rested on human fear, human communication, human judgment, and a shared desire to avoid catastrophe. So I think for me, the question isn't can we still deter in this current era? It's how do we make space for the human fear, communication, judgment, and effort? And that's the governance piece where I will wrap up. We can't tech our way out of this because we have a tech dilemma where one solution leads to another problem. We have to find our political answers. Lots of people point towards strategic restraint, so can we develop norms such as non-interference with nuclear command and control systems or non-interference with civilian infrastructure? I think that's great, but it doesn't happen just because we want it to happen. We already see ample evidence of consistent, persistent attacks on civilian nuclear infrastructure despite UN declarations that we won't do that. So I think we need to zero in on those human interactions, not unlike this conference where many people have pointed out we have a diverse geographic grouping of people, but we also have academics, NGO people, military, government. I think being able to get together and talk and share information is really important. I think we can go back to the Cold War and bring tools into use that worked in the past, hotlines, communication, and modes of interaction. But I think in today's world, we have to expand it. It's not just great powers that matter. I think it's everyone. We need to have multi-stakeholder engagement because private sector capabilities are wrapped into this technological security dilemma. And civil society is a key conduit of exchange and understanding. So I'll close by saying, I think it's important to strengthen the human layer, the decision-making layer, the layer that gives people time, that gives people the ability to communicate, to validate, to doubt, and have human connection. Because at the end of the day, we're not really talking about protecting technical systems, we're talking about protecting people. Thanks.
Brilliant. Thank you very much, Dr. West, for highlighting the fragility of digital deterrence in an increasingly connected world. You have made some very important points. The way you said that cyberspace has made things complex, fast, and very hard to explain. Especially how you have creatively talked about first strikes, entangled instability, and non-nuclear threats. You have left food for thought for when we talk about the logic of nuclear stability, is it collapsing or not? And one last thing that I would add here is that if it wasn't really weapons the way you said, but it was men and the thought process of humans that created stability. So will that be the case in this age? So now with these words, we'll move to our third speaker, Dr. Letitia Cesari. She'll talk about emerging applications and impact of directed energy weapons. We all know that now directed energy weapons themselves are no more a domain of science fiction. They're progressing really fast in the real world. Now I'll give a little bio of Dr. Letitia. She is a consultant at the United Nations Institute for Disarmament Research. She is a researcher and a legal practitioner working on the law and policy of digital technologies and outer space with a focus on security and safety aspects of things, and particularly cybersecurity. Prior to this, she was in a position where she worked with the space industry, especially in telecommunications. Before that, she supported the work of national authorities on space-related topics. Dr. Cesari, we're eager to hear your views on this new frontier. Please proceed.
Thank you very much, and thank you for kindly inviting me. I'm very sad not to be here today, but I'm happy to join remotely from Paris. My name is Letitia Cesari, and I am a consultant for the United Nations Institute for Disarmament Research. But before I start, please note that I'm speaking in my personal capacity and not as a representative of the Institute. So I will first mention some historical background on directed energy weapons technology, because they have been developed over the past centuries, especially at the beginning of the 20th century, with some research on physics and light, on photons and particles. And all of this was facilitated by various people, like Max Planck, or for instance, Albert Einstein's concept of stimulated emission of radiation, which he put forth in a paper delivered in 1916. But the first functioning laser has been built by the researcher Theodore Maiman, working with Ruby, the rock, to amplify light and using specific lamps in order to develop laser technologies. So laser mean light amplification by the stimulated emission of radiation, and he published his results in the weekly Nature in August 1960. It's very interesting to see how from this technology that was developed over decades and worked by different people all around the world, very, very easily the first use that was identified was the military use. And during the Cold War period, the two blocs were very interested in technology development, and they started to invest in research and development in directed energy weapons with a particular focus on laser and particle. And it became very fastly a part of their defense strategy for various purposes, but mostly to shut down ballistic missiles. So many experiments, many developments were focused on this type of applications. And it was very much related to all of the tensions regarding the nuclear systems. And a few decades later, from the 1990s onward, other states started to invest in these technologies until now with specific initiatives like we can see with the domes. The question of directed energy weapons is very much raised, or orbital anti-satellite technologies, and I will come back to this a bit later. So this technology, while originally developed for military uses, have civil importance to be on application for health sector, for the industry, for outer space communication. And it's more and more developed also because it's extremely precise and it allows for more specific uses for the tissues, for instance, in medical applications, for the eye as well, because it's much more easy to use, for instance, a laser than a scalpel, and it's more precise, as I said. Same for the industrial and manufacturing, surface treatment. And what we can see is the use of the light and concentrated light directed to a specific place for space optical communication. Also, the notion of quantum was mentioned before. So this quantum key distribution can be spread through light, and so on and so forth. So we see more and more civilian applications related to laser and to directed energy. But as I said, one of the big application is disruptive technologies, disruptive applications. And we can see that some reports were submitted and released by various experts. And I used here one of them, a report of the Secretary General of the United Nations that was released in 2021 and entitled Current Developments in Science and Technology and Their Potential Impact on International Security and Disarmament Efforts. And in this context, in this report, 3 types of disruptive electromagnetic technologies have been determined. So the directed energy weapons that are the topic of today, electronic warfare capabilities, and electromagnetically propelled weapons. So let's say also that the directed energy weapon is used as a catch-all to encapsulate a number of different technologies under one umbrella. I will come back to this a bit later, but these technologies are all at different levels of maturity, also depending on the states working on research and development. And what we could see is that they can be embedded in some specific systems that are on the ground, on the sea, on the air, and to a certain extent, there are questions related to the development of this type of capabilities in outer space. So these technologies have limitations, and one of them relates to the type of energy and the quantity of energy that can be used. So of course, when they are located on the ground, it's a bit easier to bring energy and to actually beam a specific type of technologies. So for instance, laser or particle or microwave. And because it's also extremely challenging to have technologies that will not be located. And that's one of the big points. How can we use a specific disruptive capability without being seen? it has been put on mobile systems, so sea-based systems, air-based systems, and that's also why there are more and more research showing that there are developments on space-based systems. Now, directed energy weapons are, as I said, the catch-all term, but if you are more interested in the specific definition, I will refer you to the commentary written by my colleague Sarah Grand-Clément on directed energy weapons for the UNIDIR in 2022. And what she identified is that it's the use of concentrated electromagnetic energy or charged particles, for instance, lasers, as I said, microwaves, particle beams, with a specific purpose. It's to disable or destroy targets without relying on a physical projectile. And we also kind of call it the non-kinetic systems because this notion of physics, and I will spare you with the details, but this notion of physics is very important because you need to acquire and harness this technology in order to use it. And not all of the states managed to use it over the years or managed to use it efficiently and from a very far location, which will be extremely useful for specific uses. For instance, if the target is in airspace or to a certain extent, and that's, as I said, a big question mark, if the target is in outer space. So what effect can directed energy weapons achieve? So we have the lasers. They are high power or low powers. And this can lead to the disruption and destruction of equipment. But the target in general is very much the electronics. It's very much the very sensitive equipment. For instance, the optical or specific radars that are put, they are so sensitive to physical phenomena that using this type of directed energy weapons can be extremely efficient. And this is exactly what my colleagues before said. We have more and more technologies embedded in various sectors, and most of these sectors now are very critical. And sometimes they are very critical for national and defense interests. And if they rely on technology, to a certain extent, is more efficient to target the electronics on which this technology is supported than actually like the shield or the very material. I will come back to this a bit later, but that's one of the purposes of using directed energy weapons. You also have the high power microwaves that can degrade and damage electronics, as I said, and as such, they can be used to counter threats from uncrewed air-based systems. And that's one of the big type of uses we see because uncrewed systems, such as drones, for instance, they cannot be easily reachable. And having high power microwave able to disrupt its electronics can be very, very efficient. There are also particle beams that can hit a target object with a stream of accelerated particles. And same, this type of technologies is not developed by all of the states, but we can see some uses in some experiments, and we can see that research and development in specific countries is very advanced. And millimeter waves that are kind of different because they are more anti-personal area denial weapons. One of the use is to produce a burning sensation on the skin, and it's extremely difficult to prove the use of this type of waves because they are so peculiar, and so identifying this use, identifying this burning sensation is very, very difficult because it disappears as soon as it's activated, let's say. So it's also about, as I said before, trying to find the origin of the source of power. And if it's ground-based, if it comes from a specific place to a certain extent, it's easily located. But when it comes from a mobile source or from a specific system that can be taken with the hand or located on the sea or on an airplane, it's much more difficult. So it's very interesting type of technologies for strategic reasons that states started to develop. Now, regarding the types of targets, so the United Nations worked on trying to reduce tensions and to identify some of the most efficient systems that are being developed now. And in July 2024, there has been a release of the report of the UN Secretary General on the same topic, as I said before, current developments in science and technology and their potential impacts on international security and disarmament efforts. And in this report, paragraph 63, the Secretary General team identified directed energy weapons as one of the disruptive systems. And in this paragraph, we can see that they identify two targets, so air-based and space-based. Air-based is more easy to show because we have actually videos that can prove this type of experiment by specific defense and military forces. So as I say, the target is mostly includes vehicles, rockets, missiles, incoming munitions. And in the context of the nuclear field, being able to disable or to damage a missile that is incoming is extremely efficient because it can actually put at stake some of the systems launched by an adversary or by a state rival. And to a certain extent, these capacities, they can destabilize deterrence and eventually prompt an arms race or preemptive behavior. But at the same time, they could also, because of the defense it allows, it enables for the different states, it could also perhaps deter aggression by reducing the perceived payoff of a strike. So for states, it's about finding a balance between having these systems, experimenting them, showing an adversary that can be a very good defense and that their attack can be actually cancelled and neutralized. And this question is whether this type of technology can, because this defense is so strong, deter any aggression, any missile, any uncrewed air-based vehicle. And that's still a question. So I put it here, and I'm asking you all the question regarding this, but that's discussions that diplomats are having on whether it will increase miscalculation, miscommunication, misperception, or whether it will actually be helpful to straighten the defense and to deter aggression. And I put a question mark here. There are these questions regarding space-based targets. As I said, it requires a lot of energy, a lot of power to beam a specific signal and to be able to reach a target. You need to target, you need to have the good aim, and you also need not to have physical phenomena. I will come back to the limitation a bit later, but you need a lot of conditions in order to have an efficient systems like this. But it's still a question mark regarding whether this type of systems can be used as a counter-space capability. If it is, indeed, we know that the satellite components are full of electronics, are full of very sensitive optical radars, satellite imagery technology, and so on and so forth. So one of the issues with having this type of systems, and as I said, we can see some research and development, we cannot prove the use or operational system. This has not been at least made public, and it has not been proved. But if it's becoming operational someday, it can increase the risk of misperception, and it can increase the risks of tensions in space activities. So this is the reason why it was very important to put it on the paper. And the fact that it's on the report of the Secretary General is very interesting, because it means that for diplomats, for the international community, for the NGOs that are taking active part in the discussions, it's a topic to focus on when they are going to work on disarmament efforts. So why is it important? Also, because when you have your target and when you manage to reach it, it has specific disruptive effects. What we can see is that it has reversible, so temporary effects, or irreversible effects, so it's permanent, and it can be very disruptive. So this table comes from the report I mentioned before from 2021 of the Secretary General. And depending on the type of directed energy weapons used, there are different effects. So you have the low power, so from the bottom, you have the low power lasers that are a part of the directed energy weapons, possible effects, dazzle, and disruption, but it's reversible, meaning that when you switch it off, eventually these disruptive effects, they disappear. And that's also why it was important to say that sometimes it's difficult to prove because your system was switched off or was just disabled with, and then this disruption disappear. So did it really happen? Eventually, yes. Now, how do you prove it? And how do you prove the source of the disruption? These are a very big question. And then regarding the irreversible effects, they are ranging from the microwave with high power to the laser with high power to the particle beams that have very disruptive effects and very permanent effects on the different systems that can also, to a certain extent, qualify as a physical effect because the disruption is so bad that the physical components are damaged and cannot work anymore. And this is a very important thing to take into consideration because we can see that when it has a physical permanent effect, then it has the same effect as any striking hit-to-kill capability. And you cannot switch it off. So what do you do? And in terms of international law, it raises questions regarding the threshold of the use of weapons, the use of aggressive capabilities to a certain extent, and to what extent do we consider this as triggering specific tensions between states? So these are considerations that can be discussed at the multilateral level, but also in terms of policies at the national level. What do we agree and what do we not agree to develop as a state or as a military power? And what messages does it give? Is it only to undermine an adversary capability, or is it to permanently destroy its systems? And that's some of the questions that can be interesting for international lawyers in the room. So we also have to keep in mind, as I said, that directed energy weapons have operational limitations. So first, it's a physical system with physical conditions to be put and to be interesting. So the line of sight is required. It can be sensitive to the performance. It also face material resistance. So on this, as I said, there are discussions on the co-orbital capabilities, and I recommend you to have a look at the Global Counter Space Capability Report edited by Secure World Foundation that shows to a certain extent how this type of technology are developed and under research at the moment without being operational. And on this, this concludes my presentation. Thank you very much.
Thank you, Dr. Letitia, for your compelling take on the real-world consequences of the fast-developing class of these weapons, especially how they are being developed at all domains like air, land, sea, and space. Example is that they can be used as anti-satellite weapons, and they can be used on the tactical level as well through millimeter waves. That was brilliantly done. And I think I would just state one line here is that I think you are the first speaker for us Pakistanis who came forward and talked about intricacies of directed energy weapons. This is the first time in Pakistan, at least in academic circles. Thank you very much. Now we move on to our last speaker of the session, our very own Dr. Rizwana Abbasi. She'll talk about laws, escalation dynamics, and global security. As we know that lethal autonomous weapon systems introduce a unique form of unpredictability. Without a human in the loop, how do we ensure accountability? And we also need to ask that, can deterrence be stable if machines make the life and death decisions? So I'll give a little bio of Dr. Rabia Abbasi, Dr. Rizwana Abbasi. She is an associate professor at the National University of Modern Languages, Islamabad.
Now professor, now full professor.
Yeah. And now, yes, we have to announce she just recently became a professor. We should, yeah. It just happened this week. So congratulations, Professor Abbasi. And she's also a non-resident fellow at our institute. She's a former fellow at the East-West Institute, Stimson Center, and Central European University. She has taught at leading institutions in Pakistan and the UK. Dr. Abbasi holds a PhD in international relations from the University of Leicester, UK, and is the author of four books which are really important for us, which are on nuclear deterrence, disarmament, South Asian stability, and her recent book has been about emerging technologies and their impact on deterrence. Over to you, Dr. Abbasi.
Thank you so much. Ladies and gentlemen, first of all, Assalamu alaikum and good morning. I am really grateful to the CISS Forum for giving me this opportunity to speak to you on this occasion. More so, I would like to congratulate Ambassador Naqvi for organizing this highly relevant and timely conference. I was asked to speak and talk about lethal autonomous weapons, which are called LAWs. So ladies and gentlemen, lethal autonomous weapons are not one or two particular categories of a weapon system. These weapon systems basically are autonomous weapons. By extension, I would say that any sort of machine capable of performing military operations autonomously is actually called lethal autonomous weapons. So autonomy basically is the capability of machines to perform a task without human intervention or supervision. So notably, lethal autonomous weapons or laws count on capability driven by algorithms. These systems can operate across various domains such as aerial, land, maritime, underwater, and extraterrestrial environments. So I would like to very precisely talk about growing trends in proliferation of laws. So militaries worldwide are increasingly developing advanced weapon systems powered by AI while simultaneously transforming their military doctrines and strategies by integrating these weapon systems. The conflict zones such as Ukraine, Russia-Ukraine war, Palestine, and Libya suggest that the weapons with some autonomous capabilities may already have been used, thereby revolutionizing the battlefield. So specifically, AI-led armed drones are a game changer. Drones are, and certain other weapons with varying degrees of autonomy have become commonly used by high-tech militaries in numerous international conflicts of this century. Countries such as China, Israel, Russia, South Korea, Turkey, the United Kingdom, United States, and now I would like to add to the list is India, are reportedly investing in advancing autonomous weapon systems such as swarm drones, killer robots, space-based technologies, cyber technologies, hypersonic missiles, and so on. Ladies and gentlemen, robots are being built that can be made smaller, lighter, faster, and more maneuverable. So these can stay on the battlefield for longer without rest and can take more risks, I would say even suicidal missions. So land and maritime vehicles with autonomous features are also being built internationally. So I would like to very precisely shed light on how laws revolutionize the battlefield. So laws are mainly designed in military missions for surveillance, intelligence, and combat missions. So ladies and gentlemen, I have just figured out that laws basically perform dual tasks such as how they march from the setting inside out. First, I would like to talk about that. Initially, laws are equipped with various sensors to collect and compile environmental data. The data then is processed and fused using various algorithms. This process then enables the laws to detect and navigate targets, identify patterns and irregularities in the settings, and then classify objects and situations. In the inside-out setting at the second stage, then laws process data, which is then fed into an AI-led decision-making process, which analyzes the data, gives situational broader, quick awareness, evaluates potential courses of action, and then it selects the optimal actions, in order to launch the target. In this whole process, it also involves builds human machine interface. For example, currently, laws are not yet fully autonomous, but they are actually into that process, but laws prepared to operate at this stage autonomously, thereby involving human oversight or intervention for necessary input or corrections in order to override AI. So within this, the most important aspect of laws is that they readjust as a matter of fact to the changing environment. So laws learn from an environment, they improve their performance. With the passage of time, with their operationalization, they readjust to the changing environment and then start performing autonomously according to the evolving situation. Now, precisely, I would like to talk about laws and their operationalization in the battlefield, how they perform from outside in, the settings and by, giving operations. So laws are anticipated to be far faster, more agile than today's man-made machines. Laws are expected to operate in large swarms comprising 100 or even 1,000 of small, relatively low-cost and expandable vehicles with networked sensors and onboard computing. Due to their speed, surprise, and survivability, I would say that laws might be more adept at conquering, at this stage, adversaries in air-to-air combat. Laws are capable of detecting and tracking targets with precision by swiftly calculating and pursuing actions, thereby minimizing collateral damage. Such cost saving could be applied to the other military functions such as logistics, transportation, battlefield healthcare, cybersecurity, and combat simulations and training by minimizing the demand for manpower in the battlefield in the near future. Laws offer the capability of synchronized broader attack defense that capable one to fight inside the enemy's decision cycle loop, which is called OODA, which means observe, orient, decide, and then act, overwhelming and defeating the adversary's abilities through mass intelligence, coordination, and high speed and precision. Now I would like to very precisely shed on laws' impact on escalation dynamics and strategic stability. Ladies and gentlemen, AI-enabled laws will significantly impact the battlefield, thereby testing strategic stability. The space for miscalculation under autonomous high-speed weapon systems has increased, thereby decreasing the ability of human rationale. AI is brittle and could result in malfunctions that affect states' confidence in their second strike capabilities. The integration of AI into conventional weapon systems and military command is predicted to create miscalculations, misperceptions, and escalation, which could change actors' broader incentives to engage in erupting military conflicts and actions. So a state facing an adversary with autonomous weapon system capable of making decisions at machine speeds is likely to fear the threat of surprise attack, a threat that would, I would say, compress the amount of time for strategic decision making. This point is very important. The posturing of autonomous weapons during a crisis situation, I would say, would likely create fears that one's focus could suffer a significant, if not decisive, blow. So these fears, in turn, I would say, could translate into pressure to strike first, to preempt, for fear of having to strike second from a greater, I would say, vulnerable position. So similarly, within the conflict, the fear of losing at machine speed would be likely to cause a state to escalate the intensity of the conflict, possibly even escalating to the nuclear level. The speed associated with laws could potentially threaten first strike stability in a crisis situation. The ability to fight at machine speed means a state would win faster, but at the same time it means that a state can lose faster. So countries could fear that an aggressor using laws or related systems operating at machine speed could quickly knock out the C2 system capabilities, eliminating their potential to retaliate. This fear, in my view, would create incentives for many, of the least stable military postures, including strategic weapons, on high alert. A country fearing it might not have the ability to respond in time if its C2 capabilities are devastated by a machine speed attack could also have incentives for pre-delegation. In my view, autonomous weapon system could therefore place pressure on escalation control mechanisms as well. There will be a decision gap, and huge decision gap, between the operational effectiveness sought by military commanders and the requirement of political leaders to retain control of even before major escalation takes place. So the time for exchanging signals and communication and for assessing diplomatic options and off-ramps will be significantly foreclosed. So, ladies and gentlemen, laws work on precision strikes and may eliminate the danger of human casualties for the initiator of the attack. They nonetheless led them to an increased propensity of use and enhanced prospects of symmetric, in my view, symmetric and asymmetric responses, thus and thereby lowering the threshold for application of force in armed conflicts. A low threshold will then in turn increase miscalculation and trigger conflict escalation. Once conflict escalation takes place, then its dynamics become unpredictable, specifically when the target state does not possess corresponding precision strike capabilities. Laws can therefore have unintended consequences in terms of civilian casualties and damage to the infrastructure, in my view. So in other terms, I would say that retaliation then increases the chances of broader collateral damage. So law rely on complex software and connectivity, making them vulnerable to cyber attacks is high. Malicious actors can exploit vulnerabilities in these systems, potentially manipulating their intended functions and possibly, hacking the systems. So in the era of algorithm, uncertainty grows high. And then, of course, unpredictability is high, and codes which can be hacked to degrade or can be deny operational capability. So I would say that, interestingly, laws have undermined the legitimacy of international legal mechanism, international non-proliferation regimes, protocols, and of course norms. The arms race is at rise in regard to laws. The effectiveness of existing arms control regimes has decreased. So many countries are developing these systems to gain a strategic edge and advantage in a resource-constrained environment, thereby undermining the established global rules-based order. Finally, very quickly, I'll go through and talk about global regulatory mechanisms dealing with lethal autonomous weapons. The international debate is in place on regulating lethal autonomous weapons. Nation states, through the UN Forum, together with international advocacy groups, apply increasing pressure, on states to impose legal binding international treaties and mechanisms to govern these weapons, thereby, asking bigger powers to put pressure and, sign some sort of commitments. But these bigger countries, they refrain from any such sort of commitments so far. CCW is a global convention on certain conventional weapons, is a framework where which is integral part of international humanitarian law. That forum basically aims and initiates debates to prohibit or restrict weapons having excessive and indiscriminate effects. So since 2016, there have been several discussions on this particular forums that basically talks about banning, these, maybe regulating these laws. So on ethical and normative grounds. But since 2018, interestingly, UN Secretary General Antonio Guterres has basically maintained that lethal autonomous weapon systems are potentially unacceptable and morally repugnant, and has called for the prohibition under international law for these possession of these weapons or maybe instruments. So he basically called for introducing a protocol by 2026 banning basically and prohibiting possession of these weapons. So I would say that my very crisp point is on way forward, just I'm trying to wrap up, that the discussion happening under the auspices of CCW should be sustained to establish international regulations through the development of a new protocol outlining the prohibitions and regulations of autonomous weapons to ensure adherence to the international humanitarian law in alignment with the goals of the CCW. My further point is, and notwithstanding the significance of the ongoing CCW discussions on the humanitarian aspects of the development, deployment, and use of laws, it is equally important that the international discourse focuses on laws and also fully covers and addresses the military and security dimensions of laws. Particularly, I would say that the points I have highlighted in my presentation are very important. So beyond the CCW framework, there is also a need for stability implications of military use of autonomous weapons and framework for regulating such weapons at the global and the regional level. So the nuclear powers should be more open about their commitments to human control in the use of force, including in C2 and C3 systems. So they should clarify their intentions by providing reassurances not only to each other but also to the international community that a human will always be and will be the appropriate resource when using force. So finally, I would say that addressing uncertainties and competitive dynamics of military AI would also require CBMs, confidence building measures, which would facilitate information sharing and increase transparency between states developing laws. The proposal tabled by Pakistan regarding an international legal protocol governing laws under the CCW forum is very significant, which basically offers and calls for realistic and practical solutions. So I would recommend you to download that resolution and please read it through. It carries a holistic approach on addressing how to minimize human control on the regulate and prohibit these weapons, thereby minimizing human control on such machines. Maximizing human control and minimizing automation on these machines. So finally, I would say that in the scholarly community, we academicians and the relevant forums should continue building a clear understanding of the dangers these weapons yield and bring to humanity, and create momentum for fostering such sort of debates, trust and confidence building measures at the states level and on the global forum. With this note, I would like to thank you all for bearing me, and I look forward to seek your questions during the question and answer session. Thank you so much.
Thank you very much, Dr. Basi. So one striking point that you mentioned is that the posturing of laws during conflicts and during crises can create fears, and that can also trigger maybe pre-delegation, preemption, striking first, miscalculations, and these are all the major things, major fears that we already talk about in nuclear domain. So just imagine that the nexus of laws and nuclear buildup, how does that work out in the global nuclear order, and also the regional asymmetries when they're there in the field. So thank you very much. Now we open the floor for questions. Because we have we are short of time, we would take a set of 3 questions first, and then we'll see how we go from there. Yes, Christine?
Thank you. Hi, Christine, Fellow, National Institute for Deterrence Studies. I loved all of your presentations, and whoever wants to pick this up. I'm really interested, it was so thought-provoking. Like the concept of arms racing, as the concept of it and the history of it. I mean, intelligence is never perfect, but I'm really interested in how do we conceptualize, how do we think about arms racing in the non-physical world? Just interested in your thoughts about how we kind of, how do we think about it? Sorry, big question.
Who would like to answer that? Yeah.
Assalamu alaikum. I'm Zishan. I'm associated with Strategic Vision Institute. My question is from Dr. Izwana Abbasi. Ma'am, you talk about laws and its usage in battlefield and its development. do you think the laws will make the role of traditional soldiers in the battlefield obsolete, or their role will remain relevant along with the development of laws? Thank you.
Thank you very much. I'm Sajjad and I teach at IBA Karachi. My question is directed to Dr. Jessica West. You have scared us a lot about the vulnerability and the cyber attacks. So this reminds me the idea of the argument of Thomas Hobbes, who was saying that we are in a man living in a pre-civil era where, and the natural state of nature, in which they are vulnerable to each other for the attacks, and then they civilized and formed states to protect themselves. And we are still vulnerable for these cyber attacks. So are we heading back? Are we going back to that state of nature again? And while this also provides a window of opportunity to cooperate at the global level in order to avoid such attacks. So is there anything happening at the global level? And my second question is directed to Professor Abbasi, that while you mentioned the autonomous weapons, and this is in, it's a follow-up question again, which the gentleman just asked. Do we see that there will be less guilt, or in terms of when you use autonomous weapons in the killing of, in the collateral damage and the killing of the civilians in combat warfare? Are human beings or the militaries, they are trying to getting away from the responsibility of collateral damage while using autonomous weapons?
Could you repeat the last point for me?
Yeah. So in terms when, if we can imagine a future in which more autonomous weapons are used in combat warfare, are the armies, will the armies be trying to avoid the guilt of collateral damage and killing civilians?
Who would like to go first? Yes, Ms. Jessica.
Yeah, Christine, I feel like I should have had an answer right away for your question, because I look a lot at arms racing, so it's really provocative or thoughtful to think about what that looks like in the digital realm. I think it looks very different, and I'll explain why, and then I think it's more dangerous. So it's different because there's deniability and hiding. And so I think often in arms races, we're used to seeing military parades. Look at my shiny new weapons. Because you're trying to deter, look what I have, and trust that this is what I have so that I can possibly deter you. And it's not that way with digital capabilities. They're hidden, we deny them, we're very ambiguous about how we're incorporating AI per Alice's presentation yesterday, how we might be incorporating quantum. And so it's shrouded, but then I think it makes the arms race more acute, because we also probably have a tendency to then overestimate what others are doing and to feel our own need to move faster and faster to keep up, because we are uncertain about the capabilities of others. So I think it makes it more acute and more difficult to develop a common understanding that is needed to rein that in, even if states would like to rein it in. And so I think being a bit more open is one way forward. I love the question on vulnerability. I never got to talk about my PhD dissertation, which looked at national defense and public health and how they're entwined. And the core message of that was really that, not being vulnerable is a myth, and perfect security is a myth. We always strive for it, and so I followed this effort from quarantine and physical walls around cities to civil defense measures, which came in after states realized they were vulnerable to airplanes, so distance was no longer a protector, and then missile defense and this myth again of invulnerability. I think we have to accept that we're always vulnerable. Everyone is always vulnerable, and I think that can help us at the global level hopefully arrive at more stable cooperative security measures if we can let go of that myth. Do I see that happening? I mean, there's talks about talks, but I'm not seeing a lot of core process. And again, I think it's because there's so much uncertainty right now about states' capabilities and intentions.
Dr. Rizwana?
You guys have posed difficult questions. I would like to just ponder a bit. First of all, I would say that somebody talked about understanding, evolving arms racing pattern in the non-physical domain. I would like to say that, of course, how do we basically judge and evaluate it when states try investing more and more into their AI-led capabilities, and then they, at the same time, integrating these AI-led capabilities into their weapon systems. For example, how we assessed in Ukraine, Russia, and of course, US-led support system played significant role in militarizing AI and deploying it in the war zones. So that is a crystal clear fact that it actually in turn then create ripple effects and inviting extra region and other countries to follow suit. So furthermore, somebody asked a question in regard to future role of soldiers and their physical presence in battlefield. I would say that their physical presence has not minimized just right away, immediately, but considering the evolving dynamics and changing patterns of warfare, as I said that battlefields are becoming more and more smarter. There are various stakeholders, those who have played role in Ukraine. For example, militaries of the two countries were equally important. They equally, played deeper role. They are relevant, not irrelevant. But at the same time, I would say that, some commercial entities and civilians were, they jumped into the war, zone, and they also played significant role by, of course, mobilizing their actions in cyber domain, by, hacking, of course, by inflicting heavy blow to the Russian forces in Ukrainian battle zones. So that factor is also important. I would say that in terms of collateral damage, there are two particular aspects which we need to actually understand. On the one hand, laws and AI-led system minimize the collateral damage. The broader philosophy of war is that we introduced and innovated nuclear weapons to create deterrence effects in order to avert war. And the notion of victory was almost, it became obsolete. We thought that there is no fight or broader collateral damage in the battlefield in order to achieve victory, because deterrence is now the notion, and deterrence will basically play a part, philosophical part, in order to avoid war. But what we see under the nuclear domain and notion, after many decades, we have come up with a new notion of victory and fighting war under the nuclear domain. So just in this particular context, I would say the notion of victory has changed. So in that particular notion, I would say that all the players have to play an important role. But the militaries have to play smartly. They will have to innovate. Instead of heavily relying on highly expensive and bigger technologies, we will have to build reliance on smarter technologies by equipping our soldiers and the workforce involved in this whole process to understand the dimensions of changing battlefield, and then of course equip themselves accordingly in the to play in the battle zones. And also civilians have to play an equally important role. We will have to prepare them to, we cannot avoid any sort of future shocks. We will have to prepare our civilians also to absorb the shocks and prepare relevant organization and enterprises to then retaliate and strike back. Thank you.
Thank you very much, Professor Rizwana. If you want to add something, Mr. Wildesov?
Yeah, thank you. And Jessica, I think, gave a great answer about the arms racing question, but I just wanted to add on to that quickly, because it is true that those technologies are in a way intangible. But with some of these, with AI, with quantum, they do still depend on access to certain technologies or physical things. So the classic, AI tried of having access to data, to enough computational power to develop those models, and to enough talent, in terms of human talent, to sort of build those algorithms. It still depends on things like, well, funding, on how many systems you have for collecting data, or methodologies for cleaning it up and labeling it and actually using it to train AI, your capability to build data centers, sort of institutions that work on those issues in your country, or private sector institutions which work on those things, or access to advanced AI chips. So all of those things, you can in a way quantified and in a way kind of look at this as sort of competition for access to these different resources which allow you to develop those capabilities. And just one more quick point, I will say that also when it comes to a lot of these emerging technologies, I think the interesting element here is the role of private sector. So that's not something that was at all true, for arms racing in kind of a classical sense, if you think about nuclear domain, but in terms of AI, especially in terms of space now, we also have those technologies being developed by the private sector and then in cooperation sometimes with the military. So that's an interesting aspect to it. But yeah.
Thank you, Chernavsik. Now I'll take a set of 3 questions more. Please be precise and try to ask a question rather than commenting. First, I would ask Dr. Adil, then Ms. Taiba, and one of the gentlemen at the back.
Thank you for these presentations. My question is to Dr. Jessica. Yeah. So my question is to Dr. Jessica. In this whole debate, we have not focused much on the role of non-state actors. We saw Elon Musk's Starlink, how it was played in Ukraine crisis. And there could be a possibility that other private entities developing similar kind of satellite networks and using or outsourcing those in various conflict zones. There could be a possibility private entities developing drones, so drone militaries or the cyber mercenaries. So there's a concept of commercialization of wars in which non-state actors would play a major role. Dr. Jessica, this question is directly to you. How real is this fear, the role of non-state actors in this commercialization of wars, where various technologies would be produced by private entities and could possibly be outsourced to various conflict zones? Thank you.
Hello everyone, I am Tayyaba Khurshid, Research Officer at Center for International Strategic Studies, Azad Jammu and Kashmir. As we have discussed quantum technologies and how they will be integrated into the cyber domain as well. And we know that in 20th century, nuclear revolution, played an important role. In 21st century is characterized by this digital revolution in how these emerging and disruptive technologies, including quantum computing, is impacting the cyberspace. So I would just like to have comments on the deterrence in the cyberspace, and can these quantum technologies play the role of nuclear weapons, the way nuclear weapons created deterrence in 20th century? Can these cyber technologies play the role of deterrence in the cyber domain, because we know that they can encrypt the data, and in that domain, can they play their role? That's it.
Both of you, please give just one-liner questions. Just one-liners, please.
I'm a management specialist. For the last 2 days, been listening the dreadful, use of advanced technologies, emerging technologies, while we teach our students the peaceful use of artificial intelligence, quantum computing, blockchain, so many other things. So many wizards sitting over here and also on the roster. You have been talking about the devastation, catastrophe, and destruction of these weapon systems over the last 2 days. Can you please, share with us how these emerging technologies can be used for combating proliferation of weapon system? How to ensure disarmament at the international system, at the international level? How to control a flow of dual-use technologies, and how we can have oversight on the global supply chain to prevent flow of these technologies.
All right,
thank you very much.
Dr. Sufyan, just one-liner.
Thank you, Chair, for the opportunity. This is Dr. Sufyan from ATEM Center of Excellence, Pakistani Yuva College. We have been listening, most of the speakers have talked about how emerging technologies are increasing the temptation for first strike, making other states vulnerable. So my question is from the point of view of the defensive states who wants to deter. What options do they have? Can they integrate emerging technologies into the traditional modes of ensuring nuclear survivability through concealment, hardening, mobility? So any way to bolster deterrence by punishment or deterrence by denial is the only way forward. So what are your views on it, please?
All right, thank you. First of all, we would request Dr. Letitia, who's online. She wanted to respond.
Thank you very much for all of your questions. Very interesting. I will go back to the first set of questions very quickly on how do we know about arms racing in the non-physical world. And what we see is first that some of the states, they choose to make it public. They choose to put some of the systems, for instance, directed energy weapons or else, on display, and to say what they do and to do what they say in their national strategies. And this is also a strategic move in order to do some projection of power. And this is quite interesting to see. Now, we also have multilateral efforts. And this effort comes with the states willing to put together transparency and confidence building measures. So they notify each other, they inform each other, but also the work of the non-governmental entities and observers and think tanks that are using all of the information they have at hand in order to show comprehensive set of information and to publish it, which is very difficult work, requires investment, requires funding, requires people, but it's so important to help gathering information and to a certain extent show what is wrong in some of the arms race. Now, what we see also is that states are monitoring each other, and that's also, there are some very physical consequences when a system is targeted. And these physical consequences, they cannot be hidden. And this is also put together, in some comprehensive research. Now, regarding the peaceful uses and the way that we can use the technology for better, it's very much related to the theory of international relations as well, and how we can find ways for states to de-escalate. So is it about finding some way to straighten the defense? So basically the attack is too expensive and it's too complicated. So because the defense is that high, it's not useful to attack? Or is it more about negotiation and diplomacy? And I strongly believe in diplomacy and the role of multilateral efforts. And just to end about this, it's also about transparency. As I said before, it's also about communication, which is quite interesting when we see the set of information we have available online. So it's about all of us working together for the utmost good, I would say. Thank you very much.
Okay. I would just, can I just precisely add? I would just like to very precisely add that, of course, on this particular forum, as the title suggests, we were supposed to basically highlight the threatening aspects of militarization of AI. So basically, commercial use of AI, which is very important and helpful, was not the agenda of this particular forum. That is why we did not much ponder on that side. So that's actually not our area of expertise. But what throughout we academicians are propagating and promoting, and also, of course, diplomatic forums globally, that we want to retain and prosper globally through the integration and utilization of AI for peaceful purposes. But we want to create a bar between positive use of AI and also non-military use of AI. So that's the fundamental question. How to regulate the flow of these technologies? We live in a very complex world at this age. It's very difficult to monitor and regulate flow of such kind of knowledge flow. It's a knowledge proliferation basically. So of such kind of technologies in the in present era without any global legal frameworks. So I also very clearly highlighted in my presentation that the major powers and the greater powers on the CISS forum will have to take a lead to introduce new protocol for the provision of these kind of technologies on the one hand, and making it mandatory to maximize the use of human control on technologies and minimize automation. More so, finally, I would like to say that the international then kind of protocols, legal protocols, will yield a lesson for the regional countries to follow lead. So regionally, all the countries, including India and Pakistan, should bilaterally, immediately, I would say, that open up communication channel, resume CBMs, and start, working on trust building. Under that particular framework, they can then initiate risk reduction measures on use of AI, and they need to, again, bilaterally then sign sort of agreement on minimizing, losing human control over these technologies. Thank you very much.
Thank you very much. Dr. Jessica?
Sure. Yeah, the role of non-state actors comes up a lot. I won't spend too much time. I will argue that that's an intensification of a long-time trend. We've always used, I think, commercial sector capabilities in warfighting, but what's changing is the integration, I think, of dedicated commercial and military actors and capabilities. I will point you instead to some work by Almudena, who is going to be on the next panel. I think one effect is this added ambiguity and uncertainty about capabilities and intents, especially if they're used for both military and commercial, or if operators are both commercial and military. So she's done some great work on that, and she'll be on the next panel. On quantum, yeah, I hear about sort of quantum as the next nuclear bomb. I'm not so sure how that will work, because I think technology will continue to evolve. But certainly, I think on a good side, quantum encryption can ensure much more secure communication, and there's going to be a lot of good that comes from that. The dangerous side is there will be unevenness in that, and so those who have quantum capabilities will be able to disencrypt a lot of other information, and there's reports that a lot of not just states, but non-state actors are hoovering up information, even though it's encrypted now, because 10 years down the line, they're going to be able to disencrypt it and make use of it. And so I think it's going to be very destabilizing as there's an unevenness. Tech for Good, instead of taking time, I'll point you to Thomas Gonzalez Roberts. He has a great paper that I helped edit with CG on how AI can help us with space governance, and so how it can help us determine if norms are being followed, for example. So it's a great example of using tech for arms control. And I think, yeah, physical protections will really be important. Even in the digital field, we're always patching and replenishing and changing the structure of our systems so that they have more hardening. It's just that we also continue to try to undermine those systems. And so it's sort of an ongoing loop, if you will.
All right, Mr. Vildesav, just quickly.
Yeah, thank you. Yeah, I'll just also add some positive aspects, I guess, because it is all doom and gloom. But I think, yeah, I think most of those risks come from imbalance, as you've mentioned, and the lack of transparency, really, which leads to these sort of overblown threat perceptions or misperceptions at the strategic level. So integrating these emerging technologies in a more transparent manner, paired with confidence-building measures or actual governance initiatives which target those risks, can actually be stabilizing in the end in terms of creating stronger deterrence for states with smaller arsenals, for example, or just in general improving security situation in regions. And in terms of proliferation control, I also wanted to add, so I think both quantum and AI certainly have a lot of potential, especially quantum sensing, in aiding in countering proliferation of nuclear materials, for example. I'll focus on nuclear just because that's my area. So, for example, detecting proliferation of nuclear materials through quantum sensing of certain isotope compositions, for example, part of the IAEA, or detecting even sort of early preparations for nuclear tests, I think are all, potentially would be possible uses, or even disarmament verification measures, which would deal with usually very sensitive issues like verifying dismantlement of specific warheads without sort of revealing their design. I think here also there is a role for this combo of AI and quantum. But I'll stop here because
yeah, we don't want people waiting for lunch.
Thank you so much.
Thank you very much to our outstanding panel for their timely and thought-provoking presentations. We'll now transition to our next phase of the conference. Over to you, Mr. Hazeeb.
Thank you, esteemed speakers and the moderator, for such a wonderful discussion and such valuable contribution to the conference. Ladies and gentlemen, now I would like to invite Executive Director, Center for International Strategic Studies, Ambassador Ali Saba Naqvi, to please come forward and present souvenirs and present shields to the speakers. Now I request Mr. Vladislav Chernesky, Research Assistant at Stockholm International Peace Research Institute Weapons of Mass Destruction Program, to come forward and receive the shield. Dr. Jessica West, Senior Researcher at Project Plowshare. Dr. Rizwana Abbasi, non-resident fellow at Center for International Strategic Studies, Islamabad. Ms. Anam A. Khan, Associate Director at Center for International Strategic Studies, Islamabad. We would also like to extend our gratitude to Dr. Letitia Cesari, who has joined us virtually today and enriched this gathering with her valuable insights. While we regret that we cannot present her with a physical participation shield, we will ensure it reaches her through alternative means. Ladies and gentlemen, now we will take a 1-hour break for lunch and prayer. The conference will resume promptly at 2 p.m. Kindly ensure you return on time so we can continue with the scheduled sessions. Thank you.